Good evening. All right, welcome back to tonight's class. We have a couple of questions to solve, and we'll be solving questions on several topics, ranging from polynomials to logarithm to sequences and series. And I would really love you to pay real attention in this class because there are several questions to solve. All right, let's start with this very first question. Given a function defined by f of x, which is equals to x squared minus 7x, this is your function. Given a function defined on this, we are told to find the value of t for which f of 2t is equals to 30. This is a past question, and it's very important you pay real attention so that you would always know how to solve questions of this form. So you are given the polynomial f of x being equals to x squared minus 7x. Of course, I'm sure you understand that if you're told to find, for instance, let's say you are told to find f of 1, then that would mean you are putting 1 as x. That will be 1 squared minus 7, 1. If you're told to find f of 2, you're putting 2 as x. That will be 2 squared minus 7 times 2. All right. Now, paying attention to this, you can see that you are told to find the value of t. It's different now because you're not told to find f of 1 or f of 2. You're told to find the value of t for which f of 2t is equals to 30. That means we're told now that f of 2t, that means in this case, the argument of 2t is representing x. So instead of x now, we'll be having 2t. And we're told that when we fix in 2t into this equation, we are to get a value of 30. So in that case now, we are asked to find the value of t. So what do we have to do? Well, we go on to act like we are finding f of 2t. And that will obviously be replacing wherever you see x with 2t. That will be 2t. Don't forget to use your brackets. Everything all to raised to the power of 2 minus 7 into 2t. All right. Now, you are told that this value from this particular equation, that f of 2t give you a value of 30. So you can go on to expand this. That means open this bracket. That will be 4t squared minus 14t is equals to 30. This is 4t squared minus 14t minus 30 is equals to 0. All right. Now, what you can have here, you can see this is already in the form of a quadratic expression. So in order to simplify this, I can go on to divide all through by 2. If I divide all through by 2, I'll be having the value 2t squared minus 7t minus 15 is equals to 0. So we can go on to solve this quadratically. And if I go on to solve this, of course, I'll be looking for the factor that gives me the product of minus 30 and gives me the sum of minus 7. That obviously will be minus 10 and 3. Minus 10 and 3 will give me the factor I'm looking for. So I can have 2t squared minus 10t plus 3t minus 15. All right. Now, if you go on to make your factorization, you'll be having 2t into t minus 5 plus 3 into t minus 5. We have 2t plus 3, and we have t minus 5. Everything is equals to 0. From what I can see here, I can see that 2t plus 3 is equals to 0, and t minus 5 is equals to 0. From here, I can see that 2t equals to minus 3. Of course, my t here will be equals to minus 3 over 2. And my t from this particular one is equals to 5. So the answer for this question, we're asked to find the value of t. I can define my t as equals to 5 or minus 3 over 2. That is it. This is how you solve questions, and you're able to always get your answer. All right. I'm sure we are all clear about this. So let's move on to the next question. Now, the next question we have, if x minus 3, if f of x minus 3 is equals to x squared plus 2x plus 3. The question said you're supposed to find f1. All right, so this is another question of which I'm sure you can see the variation in the way this question was being set. In this particular case now, in many a times you would be having your f of x as the function. But in this particular case now, you are told that the function, the argument of the function is x minus 3. Of course, this tells you already that all you have to do must always relate back to x minus 3 being the initial argument. So let's look at it this way. You have f of x minus 3. You are told to find f1. Now, what do you have to do? If you look at these two things, you can see that all you have to do is to note that for you to find the value of f1, in this particular function, we had x minus 3 as our argument. Now we are told to find f1. That means for us to find f1, we have to equate x minus 3 with 1. That means for us to find x1, our x is f1 happens only when our x was equals to 1 plus 3. That means our x was equals to 4. f1 happened when we had our x to be 4. Of course, you can see it. 4 minus 3 is 1. So that means if 4 minus 3 is 1, for me to find f1, I needed to go and fix in x as 4 in this particular expression. So I'll be fixing my x as 4. Of course, this is equals to 16 plus 8 plus 3. And that gives me my answer to be, that's 24 plus 3. And that is what? 27. I'm sure you guys can see how easy it is to solve these questions, of course, when you have the right understanding of polynomials. All right, let's solve a question on logarithm very quickly. So here is the question. Given that eight x over 4 is equals to log 381. The question then asks you to determine the value of x. All right? Determine the value of x. What do we do when we have a question like this? This is a question on logarithm. Now, you have to be very logical when trying to solve a question on logarithm. Now, I'm sure you can see what we have here. This is log 381. That means log 81 base 3. Will I be wrong if I expressed log 381 as log 3 raised to power 4 base 3? I'm sure you understand the theory around logarithm. That logarithm has told me already that if I have log y, it will be 1. If I have log 10, it will be 1. If I have log 50, you know what I'm trying to do here, it will be 1. So when we have the log of the same thing, the base and everything are the same, it gives me a value of 1. So when you see a question of this form, you see 81, and you don't know what to do. One thing you need to always try and test for is to see if we can have 3 raised to the power of anything for this particular thing, because we can see 3 here. So when we looked into this 81, we are sure 81 gave us a value of 3 raised to power 4. So what we'll do here is to express it, instead of writing 81, we express it as 3 raised to the power of 4. Now, I'm sure you understand the law of logarithm that said when you have a thing like this, we can also write it as 4 times log 3 base 3. This is a law in logarithm that when you have a power like this comes to the back here, and then you have the same thing. So this is, obviously, we are still on track. Now, as I said earlier, when you have the log of the same value as the logarithm and as the base, what you have to do is to turn this to 1. This will be the same thing as 4 times 1, which is 4. All right. So this meant I can go on to re-express this, my equation in this way. I can now write 8 raised to power x over 4 is equals to 4 now, because now I have turned the whole log 81 base 3 to the value of 4. All right. I'm sure you can go on to apply indices at this particular place. You can see that using the law of indices, 8 will be the same thing as 2 raised to power 3. And then we have x over 4 equals to 4 will be the same thing as 2 raised to power 2. The idea here is you want to try to make the same value come out, because we know that under logarithm, when we have a situation where we have, for instance, 3 raised to the power of something equals to 3 raised to the power of something. In the law of logarithm, we are permitted to cancel out these values and conclude that x was equals to 1. So when you have a question like this, you want to try and endeavor to bring everything in such a way that you can achieve the same values. So in doing that, I saw that 2 can actually happen here, raised to the power of 3. And I saw that 2 can also happen here, raised to the power of 2. So I went on to express the whole of those things as 2 raised to the power of whatever we're supposed to get. So looking at this now, I'm sure you also agree with me that the law of logarithm told me that if I have 2 raised to the power of 1 and I have maybe 2 over 3, I'm permitted to write this as 2 raised to the power of 1 times 2 over 3. That means this bracket here will make a times. So following that same process, I can write this as 2 raised to the power of 3 times x over 4 equals to 2 raised to the power of 2. All right, without wasting time, I can apply this particular law and cancel out the 2 values so that I can be able to proceed much better. All right, so let's try and see what we come out with. So I'm left with 3 times x over 4, that's 3x over 4 being equals to 2. In this particular case, I can go on to make my cross multiplication. I'll be having 3x is equals to 2 times 4. Here 3x is equals to 8. My x here is equals to 8 over 3. All right. Quickly before we continue, if you are here to give this live stream a thumbs up, do that very quickly while we continue with our class. All right. Let's take a question on roots of equation. Roots of equation. All these are past questions, by the way. I'm making a direct use of A-level past questions. So these are no random questions. They are questions that was brought out in previous years. All right. Look at this question. This next question we have. I'm sure you guys are following. Hope I'm not too fast. Please, can you indicate that you are following me and I'm not too fast? By the way, before the end of this class, my hope is to solve the question where we solved yesterday, but I'm sure some of you guys felt a bit left out while we were solving it. That was a question on sequence and series. We're going to try and solve that again so that we can put an end to that question. It's actually very simple. So this particular question said if alpha and beta are the roots of this equation, 4x squared minus 5x. I'm sure we all have our notes and we're taking good notes. I'm very sure of that because I know you guys are great students and you know the importance of having a good note. Look at the question right here. You were told that alpha and beta are the roots of this equation. Then you are told to find alpha square plus beta square. A very simple question, and I know you guys will solve this easily. But for the sake of whoever is not very great with this, I want to first of all remind you of something very, very important, and that's the sum and product of roots. You need this very much. I want you to remind yourself of the fact that the sum of roots, when we're dealing with alpha, beta, that means alpha plus beta. Don't forget they told us that alpha and beta are the roots. So the sum of root obviously means alpha plus beta. Is given as minus b over a. The term a and b here signifies the coefficient. A here signifies the coefficient of x squared. B is the coefficient of x raised to power 1. And c is the constant term. All right. And the product of roots, of course, root of alpha beta, that's alpha times beta, is given as c over a. Well, these are things you have to know. They are not they are not something you have to. There is a very great explanation for it. But since we're not doing that right now, these are something you just need to note them. You need to have them somewhere at the back of your mind. All right. Now, you need to note this, and let's quickly try and bring out our A, B, and C. Of course, this is our quadratic expression. Our A is the coefficient of x squared, which we have it as 4. Our B is the coefficient of x raised to power 1, which we have it as minus 5. And our C is the constant term, which we have as minus 3. All right. So we want to find alpha square plus beta square. How do we find the value of alpha square plus beta square? Now, this is where you have to be very smart, because alpha square plus beta square, what is this expression? How can we express alpha square plus beta square? Very, very important you note how to do this. Now, I'm going to write the expression and I'm going to prove to you why it's correct. And there's no other way to note how to do this thing than either you practice more questions and then you know all the variations of all these things, because tomorrow you may not be told to find alpha square plus beta square. You may be told to find 1 over alpha plus 1 over beta. So you have to understand how to go about all these things. But in this particular question, alpha square plus beta square is actually equals to alpha plus beta all square minus 2 alpha beta. All right. So someone is probably asking me, how did I get this? Well, this is not rocket science. This is basically just re-expression. More like how I would have written. Imagine I had x squared minus y squared. I could go on to re-express this as x plus y, x minus y. I'm permitted to do that because it's actually correct. So if you go on to open this particular bracket, you'll be getting this back. Of course, this is difference of 2 squared. So it's that same logic that flows in here. If you go on to try what I have on the right-hand side, if you go on to try this out, you will notice you will have, opening this bracket, you will have alpha square plus, I've explained how to make this expansion very easy. So it will be plus 2 alpha beta, then plus beta square, then minus 2 alpha beta. You look at this now, you will see that minus 2 alpha beta cancels plus 2 alpha beta, you're left with alpha square plus beta square. So you can see it conforms to it. So we're just re-expressing it because we want to be able to, let me point out, we want to see sum of roots and product of roots, which we can see very much clearly, which makes so much sense now. Now, from what I wrote here, alpha plus beta, we said it is minus b over a. So that means alpha plus beta is minus b over a, right? Our b was what? Minus 5. That's minus 5 over what was our a? 4. So that means our alpha plus beta, which was minus b over a, is giving us 5 over 4. All right? And our alpha beta, which is giving us c over a. Our c is giving us minus 3. Our a is giving us 4. So our alpha beta is giving us c minus 3 over 4. All right? Now, looking at this, I can then go on to fix this up into my equation. That's this particular side, alpha plus beta square, because the question told me to evaluate alpha square plus beta square. And alpha square plus beta square is giving us alpha plus beta square. So whatever I got as alpha plus beta, I will fix it in here. And whatever I got as alpha beta, I'll fix it in here. So let's do that quickly. So I know that alpha square plus beta square will be equals to, this is alpha plus beta, which was 5 over 4. That will be 5 over 4 all square. This is it. Minus 2 alpha beta, which was minus 3 over 4. Minus 3 over 4. All right. So you can see what's going on here. 5 over 4 squared, that's 25 over 16. And we have plus 6 over 4, because minus 2 times minus 3 is plus 6 over 4. So you go on to find the LCM of this. An easier way of doing this, in case you just need to learn this, let me teach you that. In order to solve this very much easily, I can decide to multiply this particular function by something that will make 16 come out. So if I multiply this function by 4 over 4, I'm sure you see that I'm going to be having my value as 24 over 16, which is still the same thing as 6 over 4. So, but I'm just re-expressing it as 24 over 16 so that I can see 16 and 16. Because when I can see 16 and 16, I can easily just say my answer is whatever was the addition of the numerator. That will be 25 plus 24 all over 16. My final answer will give me a value of 49 over 16. So that's just a very easy way of going about it without having to do a lot of long LCM. So alpha square plus beta square is equals to 49 over 16. All right. You can see how easy this is. Very easy and very straightforward. This is so let's take probably the simplest question you would ever see anywhere. Literally, somebody is saying he doesn't understand it. Ooh, that's surprising. What part of this don't you understand? I think does anybody else mirror that same sentiment, or am I communicating to you guys? Is there anything that is confusing here, or are you guys following? Let me get feedback quickly before I go to the next question. I actually thought this was very straightforward, but I thought I saw a comment right now. Okay. Okay, it's clear. Okay. Okay. All right, what I'm going to say is for that person having an issue, you can find a way to probably come back to the video, and once it's made available, or if you have to see me personally, you can come on to see me, find a way to send me a message. All right, this is the simplest question you ever see anywhere. I mean, anywhere in mathematics. This is the most simplest question. All right. So I just had to fix this here because I saw it in the past question. So why not? Let's solve it. Let's solve it since it's in the past question. I seem to sense that they love to bring out questions on harmonic sequence. I don't know why. So this is the harmonic progression: 1 over 3, 1 over 5, dot, dot, dot. Can we roll the answer back to me very quickly? Like, I just feel you should use like 2 seconds, or probably 1.5 seconds. Probably 2 seconds is too much. Give me my answer quickly. Like, you can solve this even without even writing anything. You can use your mind to solve this. Of course, you are told to find the 5th term of the harmonic progression. So I'm sure you guys remember what my definition was, because I took a whole class on sequence and series. Harmonic progression is generally defined based on your arithmetic progression. So arithmetic progression, when you do the reciprocal of your harmonic progression, you will get somebody wrote 9. That's very wrong. If you do the inverse, who is writing 9? Why are you guys writing 9? Okay. All right. So now that's better. That's better to see 1 over 9. All right. Now, if you do the inverse of, the reciprocal of your harmonic progression, what you get is straight up an arithmetic progression. So what I have to do first, which is best to do, is let me do the reciprocal of all this. I get 1. 1 over 1 is 1. And then this one will be 3. Then this one will be 5. Dot, dot, dot. So this is my AP now. What do I want to do next? I want to find my common difference. My common difference here is 2. My A is 1. I'm asked to find the fifth term. My fifth term, which I can write as U5, is A plus 4D. That is 2. Sorry, that's 1. My first term, 2 plus 4 times 2. That's 1 plus what? 8. That's what? 9. Now, this is my, don't forget, this is my arithmetic progression's fifth term. This is not my harmonic progression fifth term. To get my harmonic progression fifth term, I have to reciprocate this. So my harmonic progression fifth term will be equals to 1 over 9. Shikina. All right, now let's go to another question very quickly because of our time. Yeah, this is something I want you to pay real attention to now. This one, very simple, but of course, a bit testing. Don't forget, we are going to solve that question on sequence and series. We have to dissolve that question. That question cannot be disturbing us. I have a question on set. I would love us to solve that question on set. All right, look at this question. This one is on a very simple note. Let's see it. The question said, look at the way this question was framed. Find the remainder when the polynomial, look at the polynomial now. This is where you need to take note. 4x minus 3x cubed is equals to 4x minus 8 is divided by 2x plus 1. Now, look at this. Find the remainder when the polynomial that we have right there is divided by this. Now, I explained something in the class on polynomial today, and this is the reason why you have to ensure you understand the factor theorem, you understand the remainder theorem. First of all, can you notice something about the way our polynomial was written? But whoever is not strong enough, the person will feel what we have here is probably wrong, or there's an issue, or it's difficult. Well, this is actually very simple. All you needed to do was just remember that you are going to write your f of x as x4, x raised to the power 4, minus 3x cubed, and you bring all this inside, minus 4x, then plus 8. All right? So now, we're told to find the remainder when this particular polynomial is divided by 2x plus 1. If you remember what I told you based on factor and remainder theorem, the fact that you were told that find the remainder when a polynomial is divided by this means that 2x plus 1 is not a factor. This is not a factor, because if it was a factor, you would not have a remainder. All right. Now, the other thing I told you now based on remainder theorem is that when you fix in your value of x, in this case now I'm sure you recognize that x plus 1 equals to 0, 2x equals to minus 1, x equals to minus 1 over 2. Now, if I fix in my value of x being equals to minus 1 over 2, the value I get is the remainder. That was what remainder theorem told us. When something is not a factor of a polynomial, when you fix the value of x coming from that thing, the divisor right here, the response when you fix that into your polynomial, is always going to be your remainder. That's remainder theorem. So now the question just said, what is the remainder when this polynomial is divided by this? Now, if you go on to try and this, don't forget, these are the kind of questions that are put into your exams, and a very unsmart student will spend so much time solving them, whereas a student that is very smart will spend a very short time solving it. So one of the alternatives of solving this question is to go on to divide it literally. That means do this divided by this, and then get your quotient, and then eventually get your remainder. That'll be a very long step. You don't have to really do that. All right. What you just need to do is put in your value of minus 1 over 2 into this function. Whatever you get is your remainder. So I'll go on to find f of minus 1 over 2. This will be minus 1 over 2 raised to power 4 minus 3 minus 1 over 2 raised to power 3 minus 4 minus 1 over 2 plus 8. Of course, this will give me 1 over 16. This will give me minus 3. This will be minus 3 times minus 1 over 8. This will be plus 4 over 2 plus 8. Of course, you know that plus 4 over 2 will give me the value of 2. And this will give me the value, this will be 1 over 16 plus 3 over 8 plus 2 plus 8. All right. The same way I did the other time, I can go on. I want to add these two things together. I can go on to multiply this by 2, multiply this by 2, so that I can get the denominator to be equal to this. So if I do that, I'll be having 1 over 16 plus 6 over 16, all right, plus 10. What do I have here? I can easily have 7 over 16 now, because I can see I can easily do 1 plus 6 there. So 7 over 16 plus 10. I can go on to do the same thing that I did here. Of course, I'm just teaching you this. You don't have to always move through this route. I want to have 16 as the denominator. Of course, this is over 1. So I multiply both sides by 16 by 16, so that I can have 7 over 16 plus 160 over 16. This is just an easy way of trying to do my fractions instead of doing LCMs. If you go on to do your LCM, you still get your answer. This is just flexing of muscles, all right? So I can easily do 167 now over 16. All right? And that's my answer. So this is the remainder when that polynomial is divided by 2x plus 1. So you can see how useful remainder theorem is. All right? Let's solve this other question very quickly. This is how you are supposed to eat polynomials for breakfast, because there's actually nothing about them. They're all simple, very, very simple. All right, look at this question. We have to determine the value of a when the polynomial Look at the polynomial right here. So I want you guys to attempt this before I attempt it, because I really want you to prove to me that you have been following me all this while. Oh, sorry, not 10x. Actually, this is where we have our a value. It's plus ax plus ax. So it's divided by x minus 3. So the question goes on to say determine the value of a. So let me give you just about 3 minutes to solve this. So you have to determine the value of a. Guys, don't fall my hand. I want you guys to show me that you have been following me. So do this very quickly. Let me get your responses. Looks like we are getting several different answers. Wow, we're getting a whole lot of different answers here. How come? Wow, I'm quite surprised. Oh, you guys didn't tell me. Oh, sorry. I omitted something. The remainder is actually 100. Wait, but you guys also did not do something right. So you went on to, how do you do this? How do you actually get those answers? Because let me quickly tell you why it's supposed to be difficult for you to get those answers. If x minus, okay, I think you guys went on to say x minus 3 was a factor. Okay, you guys assumed that x minus 3 was actually a factor. So I think you fixed in x as 3 into this, then equated it to 0. Am I correct? Can anybody indicate that that was what you did? Like you assumed x minus 3 was actually, okay. You use the remainder to be 0. So you assumed x minus 3 was a factor. All right, I get what's going on there. All right, now you know what I want you guys to do. Let me just give you like 1 minute and go on to act like I actually wanted to prove you with this remainder being 100. I want you to find to solve question on this remainder theorem. So I would love you to solve. I want you to solve using the remainder 100 so that you can perfect your understanding of remainder theorem. Let me just give you like 1 or 2 minutes for that, please. Okay, 28, 22. Why are you still getting varying answers again? All right, let's solve together without wasting time. 28. Wow. Why are we having different answers? I was assuming we're going to have the same answer. 22, 28. All right, let's try and solve together. If we're told that x minus 3 was the divisor, of course, I'm sure you know that if you fix in x minus 3 equals to 0, that means my x equals to 3. So if I fix in my x as 3 into this particular function, I must get 100. That's the meaning of this equation. That means if I fix in f of 3 into x being 3 into the f of x function, I'll be having 3 cubed plus 3 square plus a3 minus 20. Now, because it's not a factor, when I fix this in, what I get is the remainder. The answer is the remainder. That's based on remainder theorem. All right. 3 raised to power 3 is what? 27 plus 9 times 3. 27 plus 3a minus 20 equals to 100. All right. 27 plus 27 gives me a value of 54 plus 3a equals to 100 plus 20. That's 3a equals to 120 minus 54. What is 120 minus 54? That will be 66. So 3a is equals to 66. My a here is equal to 66 over 3, which is 22. All right. So how many of you were able to get this solved? So this is how easy it is to get anything on polynomial. So as I said, I started today's class on polynomials with the fact that the understanding of factor theorem and remainder theorem will give you a whole lot of edge when it comes to solving questions on polynomial. So we have one question on matrix here before I go on to solve our technical question. This question on matrix, I will give you just 2 minutes to solve it. I don't believe anybody is in this class that would not, because you have done so much on matrix. I really believe you guys are so hot when it comes to matrix. So you guys will not fall my hand. I'm positive. I'm very, very positive. But it was quite surprising that in this particular year, question number 1A was a matrix question. Of course, a matrix question that has a closeness it has a closeness with polynomials. And question number 2 was also a matrix question carrying a total of 6 marks. And in that 6 marks, you were told to find the inverse of the matrix. So I believe you should lay emphasis on ensuring you can actually solve the inverse of any matrix. So let me give you I won't be giving you the inverse aspect because I think that is basic. Probably I can write the question if you want it, but basically it's the A part I want to give you. And you are given just 2 seconds. 2 seconds to solve the question. All right, this is the question. It has to do with polynomials. So we are told let A, matrix A, be equals to 2, 1, 1, 1. Of course, I'm sure you know the order of this matrix. This is a 2 by 2 matrix. And f of x, I told you it relates with a polynomial, is equals to x squared plus 2x plus 3. All right? The question then went on to say, find f of A. Find f of A. If you're on this feed on this live stream and you are yet to give a thumbs up to this video, please do that. It takes you like probably less than a second to do it. All right. So we're approaching the end of this class. We have, after this question, we have just one more question to solve, and that will be that technical question. I really want everybody to be so sound when it comes to that question. Who is giving me a value of 6? 6? Wow. What do you mean 6? Can somebody explain how you got 6? I'm a bit confused. How is f of A 6? Wow. Can somebody explain how f of A was 6? I'm literally stunned. Are you kidding? What's going on? I'm stunned. Wait, do you understand that I fixed this question here? Wow. Everybody's getting 6. You guys just fell my hand. I can't imagine I'm seeing what I'm seeing. Like, I'm stunned. I'm literally stunned. Like, you people blew me off to this night. Like, I fixed this question just as a relaxing question. I did not observe that we have a lot of issues. This is question number 1 of, I think, 2023 or thereabouts. And I think I've solved this already before. So what's going on? How did you guys get 6? I'm still wondering how you got 6. And that's how, my own confusion is, how did you get 6? And the fact that a lot of people are getting 6 makes it much more surprising, and I'm literally dumbstruck at this point. And people are afraid of picking the marker now. Because where do I want to start from? Where do I start from to explain this? Wow. Please, you guys that wrote 6 on this particular live stream, please, can you try and indicate when I see you? Please, I want to really know you. I want to know you closely. I don't understand. I want to know you. Like, I need to know all of you. What's going on? All right, that's on a lighter note. I did not expect what I saw. Guys, pay attention. Let's do this. They told us that a matrix A was 2, 1, 1, 1. That means this is the matrix A. They told us that there is a function, I believe a polynomial function, which was given like this, which was given as this. We are then told to find f of a. Guys, when you have questions like this, all this means is that wherever you saw x before, fix in your value for a now. That's the meaning, is it not? So wherever I saw x now, that means I had f of x before. Now I'm finding for f of a. What will f of a be? I'll be having a squared plus 2a plus 3. That's the very first step you guys have to do. All right. Now, I cannot imagine that I wrote this just on a very light note. Somebody's writing 18. Are you kidding? You can never get an whole number or an integer as this answer. It's impossible, literally impossible, because there's no how you want to get an whole number here. Now, a here doesn't represent anything other than a matrix, a 2 by 2 matrix for that instance. So if I'm going to find this out, I'm going to have f of a now. My a will be a matrix. That'll be 2, 1, 1, 1 square plus 2 a matrix 2, 1, 1, 1. Now, this is where I explained something to you guys. I said, when you have a situation like this, you cannot go on to write 3 here, because if you write 3 here, you will be negating the pattern that has been built. Of course, when you do this square, you're going to get a matrix. When you do 2, this is scalar multiplication under matrix. You guys have to go back to your matrix videos. I think you really need to go back to your matrix videos, because this is one of the things that was explained. If you go on to check for application of matrix with polynomials or something, we actually explained this particular question. All right. Now, you cannot go on now to, you see, somebody is writing plus 3. Of course, that's showing your deficiency on this particular question, because I already explained in previous video that has been uploaded on the channel that in this case now, you cannot have it as just plus 3. You have to go on to fix in your identity matrix. I told you your identity matrix is, it can function for some things. One of it is that in a case where you have an integer value like 3, you can convert an integer value like 3 to matrix form by multiplying that 3 with an identity matrix. So what I'll be having now will be 3 times 1, 0, 0, 1. All right. So what do I have next? If I want to multiply these two things together, we have 2, 1, 1, 1, 2, 1, 1, 1. At the end of this feed, I'm going to do something surprising, so you guys should stay tuned. At the end of everything in this class, I'm going to do something. You guys should stay tuned. All right. So I can go on to open this. This will be 4, 2, 2, 2. And this will be plus 3, 0, 0, 3. Now, I'm sure you guys are flowing with me. All right. So I want to multiply this together. This will be 2 times 2. This will be 4 plus 1. 2 times this. This will be 2 plus 1. This will be 2 plus 1. This will be 1 plus 1. So obviously, I'm sure you understand that I can write this whole thing as 5, 3, 3, 2 plus 4, 2. That's this one. This one is actually for this one, this 2. Plus 3, 0, 0, 3. All right. Now, my final answer for f of a will now be what? Matrix addition. 5 plus 4 plus 3. You multiply, you add each of the various elements on their order. So 5 plus 4 is 9 plus 3. That's 12. So the very first answer will be 12. This is f of A. The next one, 3 plus 2 plus 0, that will be 5. Then 3 plus 2 plus 0, that will be 5. Then 2 plus 2 plus 3, that will be what? 7. This is the answer. Guys, what happened? Like literally what happened? What happened? Yeah. Okay. Yeah, so now the last but not the least question. Blow off every steam you need to blow off. This is the last question. I understand they did determinant, but I don't know why they would do determinant. Like, I literally don't know why they would do determinant, because nothing about determinant is mentioned in this question. So you guys don't have to form your own question. You have to flow on the basis of whatever the question told you to do. Now, guys, the elephants in the room, we want to address the elephants in the room now. So brace up, calm down, make sure you are agile, because you can never tell where you're going to see this question. You can never tell where you are going to see this question. I would not say more than that. But brace up, all right? Make sure you are on high alert. They say if you snooze, you lose. So I beg, no snooze for this kind of time. Now, the elephant in the room we want to address, because it will not be great for the weekend that you guys left this place with a particular question posing a problem to you, and you cannot tell where you're going to see this question. So let's quickly solve it step by step. We will not waste time at all, I promise you, because at this point in time, I just want to ensure that you guys can flow without any form of distraction. Yesterday we had a distraction, which is not very appropriate when we are having a teaching. Okay, somebody is confused about how elephant take enter a room. Don't worry, let's just see. Since the elephant is in, there's nothing you can do about it. The sum of the first n terms n terms of a geometric series I told you guys, stay tuned at the end of this video. There's something coming. Make sure you stay tuned. All right. And the sum of the reciprocal is 127 over 64. All right. Now, if the first term is 1, don't forget, guys, this is the pathway to true success. So you guys that are here, you are doing really great. I can assure you, if you continue this way, you can't miss your hay. So just make sure you are focused and you pay real attention to every detail on every question. You can see how diverse our solutions are. We're solving questions on different fronts to ensure that whichever one you are having issues with, we are able to tackle it on time. Now, look at the question now. Look at the sum of the first n term of a geometric series is 127. And the sum of their reciprocal is 127 over 64. If the first term is 1, find n and their common ratio. Now, let's not have any long thing here. Number one, how do you identify the sum of terms of a geometric series? I'm sure nobody here disagrees with the fact that I am not wrong if I wrote it as Sn equals to a Rn minus 1 over R minus 1. I believe everybody understands that this is already given to us. This is a predefined formula. We are not getting this anywhere. We just have to know it. All right. Now, look at the question. They said the sum of the first term of a geometry is 127. Now, this is the general term. So let me now apply it to this question. They said the sum of this term is 127. That means I can say 127 is equals to, now they said if the first term is 1, that means my A now is 1. 1. I'm sure everybody can follow. There's no big deal here, right? Because we're told from the question that A is 1. And of course, you know that your common ratio is what we term as R. So these are A represents first term, R represents the common ratio, the N represents the number of terms. I'm sure you can define that, right? Good. Now, applying this formula to our first detail, we are told that the sum of the first n term of it, you were not told the number of terms, so we cannot fix an n value. But we're told that the sum of the terms is 127. We don't know what n was. Now, r raised to power n, we have to write our r raised to power n there because we don't know it. We don't know how, we don't know n. So we have to write it like this. There's nothing else we can write here than this. I'm sure you all agree with it. All right. So I can conclude by writing it because 1 times anything is 1 is the thing. So this will be r raised to power n minus 1 over r minus 1. So note this down somewhere. Just note this. Let's call this equation 1. If you're having a note there, just write this as equation 1. All right. Good. Now, good. Look at the next detail we're given. The sum of their reciprocal is 127 over 64. The sum, of course, this is still the same thing as the sum. We're still dealing with sum here. But we're then told that this is not just the normal series. We're dealing with the reciprocals now. Good. So what does this mean? We have a particular series. Let me assume, for instance, the series was 2, 4, 8, 16, and so on. For instance, I said, that means if they said the sum of the reciprocal is 127 over 64, that means we're assuming that we're dealing with reciprocals. That will be 1 over 2, 1 over 4, 1 over 8, 1 over 16. All right. Now, before we go on, I want to quickly tell you a quality that happens in this scenario. In this place now, you can see that the common ratio was 2 because 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. I'm sure you realize that. Let's see what happened when we had the reciprocal of that series. You can see that what happened here, we had R as 2. Our R here was 2. What was our R here? Our R here, check it out. You will see 1 over 2 times 1 over 2, 1 over 4. 1 over 4 times 1 over 2, 1 over 8. 1 over 8 times 1 over 2, 1 over 16. You can see that the same thing happened when you add the ratio. You had the reciprocal as the ratio for the other one. So this means that when you have a particular series, if you go on to find the reciprocal of that series, on that geometric sequence, whatever the ratio was, the ratio of the reciprocal will also be the reciprocal. So if the ratio here was 2, for the reciprocal it will be 1 over 2. Let's assume we have a case where R was 3. That means reciprocal will be 1 over 3. If we had 1 over R, sorry, if we had our reciprocal to be 10, if we have our ratio to be 10 for our normal series, for our reciprocal of that series, we'll be having our R to be 1 over 10. You already understand the pattern, I'm sure of that. So understanding that pattern means we can go on now to write this next detail. The sum of their reciprocal is 127. So let's go and write that here. We don't really need this again. Let's go and write that here. Of course, we'll be using the sum of terms, so I'm sure you can understand the one I just rubbed off. In this case now, the sum of term was 127 over 64. And of course, you have your A as 1. Now, if A was not 1, let's say we were told that A was 2 for the first series. If A was 2 for the first series, then in this case now, when we are trying to find for the reciprocal, our A would have been 1 over 2. But because A was 1, this implies that our A in the reciprocal will also be 1 because it will be 1 over 1. That's what happened here. So we're not just writing the same A. We have done the reciprocal, but the reciprocal of 1 is still 1. So that's why we are still going to be having our A as 1. Now, for our ratio cannot be R anymore. The ratio has to be 1 over R. So we'll be having 1 over R, as I already explained, everything raised to power n minus 1. All right? Then we have 1 over R minus 1. So I explained already, of course, 1 times anything is 1, so this goes away. Now, this goes away. I'm sure you understand why. Now, 1 raised to power n, 1 raised to power anything, 1 raised to power 1 million, 1 raised to power 10,000, everything is still 1. So I'll be having 127 over 64 equals to 1 over r raised to power n minus 1 over 1 minus r minus 1. All right, great. Now, don't forget, this was the first equation we got when we were explaining the first term. Put this somewhere. So what I want to do next now is I want to try and dissolve this thing here. I want to try and make it look better because you can see it doesn't look so nice the way it's written there. So let's try and make it look nice. So I'll be cleaning this one, but make sure you remember this formula, or probably let's write it somewhere here. Let's rewrite this formula somewhere so that we can easily call on it. I'm going to write that here. Look at the formula here. The equation rather, 127 equals to r raised to power n minus 1 over r minus 1. This was equation 1. Note it there. We derived this from the very first detail they gave us. So note that there, because I want to clean this up. I want to use this to simplify this particular term. I'm still trying to solve. This was the detail they gave me on reciprocal. So I'm trying to solve this particular one. So please pay attention. So I'm still on this. Let me try and solve this right-hand side. Then I'll bring it to 127 over 64. I just want to solve this place alone. I'm leaving this one for now. I want to solve this one so that this one looks more neater. So let me solve this. Look at, I want to find my LCM here because I'm having over 1 here. I can find LCM. LCM will be r raised to power n, right? I have a fraction here, I have 1 over 1. LCM is r raised to power n. R raised to power n goes in r raised to power n. 1. 1 times 1, 1. So I'll be having 1 minus 1 goes in r raised to power n. R raised to power n times. R raised to power n times 1, r raised to power n. All right. So that's all for this particular upper side. So let me write a very long one so that this looks more nicer for you to understand what I'm doing here. So let me solve for this one now. I can find the LCM also. Finding the LCM here. The LCM now will be r. R goes in r. 1. 1 times 1, 1. This will be 1 minus. 1 goes in r. R. R times 1, r. Good. Now, I want to look at what we have here. I want to write this now using this division as my division symbol. So I'll write it like this. 1 minus r raised to power n over r raised to power n divided by 1 minus r over r. Good. So I'm going to clean up this place so that we can maintain visibility on all these things. So look at what I have here. I'm not wrong if I write this as 1 minus r raised to power n over r raised to power n times, I invert it, that will be r over 1 minus r. So for the sake of a better visibility, I can write this as 1 minus r raised to power n, this upper one, over this one is still the same thing, over 1 minus r times r over r raised to power n. It's still the same thing. All I just did was I changed it. The reason I will tell you why I changed it. I changed it because I wanted to see this in this. I will explain that very soon. But all I just did here, I have not cheated or done anything. I just did 1 over r raised to power n over this. I just changed the form. It's still the same thing over r raised to power n. Good. Now let's stay where we are right here. I'm sure we don't need this anymore. This is the final answer here. So let me go on now to write. Don't forget this was the right hand side. So let me go on to write 127 over 64 equals to this. Because don't forget, I was just solving the right hand side here. All right, good. I'm still on this. So let me now explain something. Put this down somewhere as probably an equation you want to. We'll be talking about it now. Now look at this particular thing here. I want to prove something to you. If I go on to say, instead of writing 1 minus r raised to power n over 1 minus r, if I go on to say, I want to factorize minus outside for this numerator. If I factorize minus outside, of course, I'll be left with minus rn minus 1. Somebody says, what am I doing? I will explain to you what I'm doing. Try it and see if I'm wrong. Minus times r raised to power n is minus r raised to power n. Minus times minus 1 is plus 1. What I have here and what I have here is still the same thing. I'm just changing the form. That's all I'm doing. So I'm separating, I'm bringing out minus, and then I'm having this. And then I can do the same thing for the one beneath. That'll be minus, and then I'll be having what? R minus 1. If you want to prove this also, minus times r minus r, minus times minus 1 plus 1. So what we have here is the same thing as what we have here. Meaning that I can, of course, minus can divide minus. So I can equally say that 1 over r raised to power n over 1 minus r is the same thing as r raised to power n minus 1 over r minus 1. All right. Now I have proven that already. What this means now is that what I have here, look at this, I derived this from this particular equation. I can go on now to change. Let me write that here. So from here, I can go on now to change this whole thing to be 127 over 64 is equals to, instead of writing this thing now, I'll be writing this one here. I'll be writing r raised to power n minus 1 over r minus 1. Then times, don't forget, we still have times r over r raised to power n. You see, the reason why I wrote this is because in my equation 1, I already saw that this particular thing existed there. So I changed the form so that it can look like this, which I was successful in doing that. So now I can go on now to replace all these things now with what this was equals to. You can see they told me that 127 was equals to this whole thing. And this is the whole thing here. So instead of writing this whole thing now, I can write 127 because that's what this equation told me. So times r over r raised to power n. All right. Now, looking at this, if I decide to, this can be written as 127 over 64 equals to 127r over r raised to power n. I can multiply both sides by 1 over 127. If I multiply this place by 1 over 127, both sides, I'm not wrong. Of course, 127 will cancel 127, 127 will cancel 127. I'll be left with 1 over 64 is equals to r over rn. All right. Now, we are getting closer to a good place. I'm sure you guys are still able to cope. Now, we have gotten to a very good place. Now, please, I want you to really pay attention to this. you have r over r raised to power n is equals to 1 over 64. How do you go and solve this? How do you go on to solve this? All right. Now, look at this r over r raised to power n. R over r raised to power n, for those of you that understand this is very well, you will not have any issue with me writing r over r raised to power n as 1 over r raised to power n minus 1. Now, if you go on to express this, what you have here, you will see you will also get this particular value. What we have here and what we have here, they are actually the same thing. You can go on to prove this by having 1 over r raised to power n. Just follow the process. I'm sure you understand the law of indices that says this will be divided by r raised to power 1. Go on to follow through on those processes and you will arrive at this particular place. Now, if you still don't understand what's going on here, you can let me know and then I will find a way to explain. But just for the sake of time, and I explained this yesterday, I would want to just move on and go on to continue from here. That means I'll just be writing this equals to 1 over 64. And obviously, you know that how this is the same thing as, I don't know, I'm looking at solutions, but I hope you can see it, that it's okay for me to write it this way. I'm sure you know that this is very right. From here, from what I have here, I can write this because it's just very right. It works very much like that because I have the same thing. So I can go on to write r raised by n minus 1 equals to 64 by the law of indices. And if you want to go and prove that, we can all prove that. It's not difficult to prove. But once you know you're having issues with this, just let me know. And we can find a way to go on to explain, probably more personally now, because I'm trying to also be time conscious here. But I can explain everything, not a big deal at all. So in this case now, of course, I'm sure you can see that this is the same thing as r raised to power, sorry, this is supposed to be r raised to power n divided by r. I'm sure you understand when we have minus, that means a division happened. So if a division happened, that means I'm left with r raised to power n divided by r, which is equal to 64. In this case now, r raised to power n will be equal to 64r. I'm just following through on the process. That's all I'm doing right here. I'm not if you this is I can see this test so much on indices, this particular aspect, because I'm sure everybody could float with me to this place, but to get my final answer from here, I'm having to apply the law of indices a lot. So all you have to do is to just follow through on the process and you will never be wrong. Now, look at this place, my equation 1. On my equation 1 now, look at my equation. I told you to note this. I remember I wrote it down here. Now I've gotten a value for r raised to power n. If I go on to fix this r raised to power n here, of course, I'll be able to get my r value. I'll just say put Rn equals to 64r into equation 1. So I'll be having 127 is equals to 64r minus 1 over r minus 1. Right? So this will be 1, if I cross multiply, this will be 127r minus 127 equals to 64r minus 1. All right, bring 127r, collect like terms, minus 64r equals to 127 minus 1. So this will be 63R equals to 126. In this case, I know my R is equals to what? 2. And what I have to do next is very easy. I just have to go on to solve for R using any of the functions that gives me a convenient value. R raised to power n equals to 64. I can use that. So if I want to, I can use that. 2 raised to power n equals to 64 times 2. That will work also if I want to use that. So again, I think yesterday I took a different route. I can take this route. I can take several routes because once I get my value of R, then I'm more comfortable to use anything. You can probably even put it back here and still get your answer. So whichever one you want to do, you are actually at liberty to do it. So I want to be using R raised to power n equals to 64R, knowing that my R equals to 2. This was not what I used yesterday, but just to tell you that you can move through 2 raised to power n equals to 64 times 2. 2 raised to power n equals to, that will be what? 128. And 128 is 2 raised to power 7. So my n here equals 7. I'm sure if you remember yesterday, this was not the route I took. Just telling you that anything you want to. Yeah, exactly. I'm telling you, see, you may use a shorter method, you may use a longer method. All these things are just knowing how to apply what you know. So if you still want me to use a different route, I can still take a different route. But now you can see from this particular question, my R was 2, my n was 7. Again, guys, this is a direct pass question. So okay, so I think at this point, we can assume that we have been able to cover up a whole lot, and this is quite nice for the weekend, right? So this is a past question, and it's so nice we did it together. So I want to know those guys that are following me. So I want you to just indicate by giving me your names right now. I want to know people that are really flowing in this class, and let me know them. I'm Precious, I'm sure you're there. Tunji, I'm sure you're there. Let me have the people that are flowing with me in, like, I just need not more than 46 names. All right. Precious, I want you to help me with that. Thank you very much. All right. You have just about less than 2 minutes to do that. Just about 2 minutes. So this is the work you have to put into your studies in order to achieve A. You know, I'm sure you guys can see the quality of questions that comes out when it comes to A level. You have to prepare really solidly. This weekend was quite interesting. I think we were able to complete sequence and series. That was on Friday. Then we started with polynomials on Saturday. We completed it on Sunday, and we were able to solve several questions on polynomials too. We solved several questions, several past questions, quite interesting ones. This is one of them we just finished solving. And we've solved this before. We're solving it today again in order for clarity. And this is so nice. If you keep on doing this, I can assure you, you would really have a solid A. Yeah. So how would you like this for a Christmas gift? Like, imagine giving this. Question like this. Somebody is asking if there's a short method. What short method do you want to have? All you were doing all through this question was interpreting the if you want to talk about different courts, different pathways, it will come from almost towards the end. All right. At the beginning, there's nothing short about whatever you have to do in that initial place because we're just interpreting the question basically, and we let the ships fall where they may because you don't want to assume anything and you don't want to add to the question. So you have to just follow through on what they gave you, the data they gave you. So they gave me my data for the reciprocal sum. They gave me my data for the normal sequence. And then I used all those to get my pathway. And then from there, I was able to get my R value was first, and then I went on to get the N value. So yes, of course, I'll be uploading the videos for polynomials. I think they're all available, except the one for today, obviously. The one for yesterday is available already. So you can go on to make use of them. Yeah, so guys, tomorrow, Connie sections. All right. Connie, oh, somebody said we should have class on the 25th. Ah, that's nice, right? Of course, I'm not the one that will be teaching you. But I think we'll discuss that. We probably will have our last class for the year, probably this week, Friday, Saturday, Sunday. I don't know. We'll discuss on that. But I'm telling you, it's either one more section or nothing. We cannot have more than this week is the last. This week, Friday, Saturday, Sunday is the last possibility for me ever discussing any class for the year. I mean, a class like this. So, right. So I think we are done. I believe, Precious Tunja, I believe you have all the details I need. Thank you very much. Thank you for joining. Thank you for putting in the effort. I wish you all the best. I wish you excellent success. Keep on striving for success. Don't give up on yourself. If you have a difficult question, you can always reach out. Make sure you put in everything possible to achieve success. They say the price, PRICE, is sweat. Then, but the price, PRIZE, is sweet. All right. So you're going to put in a lot of sweat initially, but these are the moments that defines you, that defines your ability to get that desired A when you're in the exam hall and every question you're seeing is quite familiar and you look around and you're wondering, is this the question they're asking me to solve? Of course, it is these moments, this night time of hard work that will earn you that. So guys, keep on doing your best. Keep on doing the best. The sky is just the beginning. Keep on doing your best. All right. Thank you very much for the night. At this point, I'll be saying a very good night.